Hello everyone and welcome to this audio podcast. This audio podcast is part of the Ghromulin series. This audio podcast is part of the Photon Saga. This audio podcast and series are part of a Storm Robotics production. So today looking at an overview of tissue injury, and in as part of works from 2008, and looking at the role of endogenous opioids in ischaemic preconditioning in humans. So ischemia is characterized by initially cessation of aerobic metabolism, and depletion of creatine phosphate, and additionally, where there's an onset of anaerobic glycolysis, and a buildup of glycotic products such as lactate and catabolites of the nucleotide pools in tissues. Processes which begin within seconds of ischemia are resultant upon hypoxia being low oxygen, and subsequent loss of aerobic adenosine triphosphate (ATP) creation, and if long standing, this potentially leads to permanent cell damage. The transfer to anaerobic source of adenosine triphosphate (ATP) is compensatory. It's sort of compensatory, but still only comprises about one-fourth of the myocardial aerobic glycolytic rate, which eventually ceases after about 60 minutes of reduced blood flow. So now looking at vascular injury as part of tissue injury. So endothelial cells that maintain hemostasis are vulnerable to ischaemic damage, or ischaemia damage. Prolonged hypoxia reduction of oxygen reduces endothelial cell production of certain bioactive agents, for example, prostacyclin, nitric oxide, and stimulates the manufacture of other agents. So, for example, endothelin and thromboxane A2. However, explicit microvascular harm in the myocardium in the myocardium in the my in the myocardium does not appear to sorry in the myocardium does not appear until after 60 minutes or more of severe ischemia in vivo, at which time reflow is no longer possible. So now looking at irreversible ischemic injury as part of tissue injury. So the hallmark of early phase irreversible injury. So for example, where there's adenosine triphosphate (ATP), and secondly, high concentrations of hydrogen adenosine monophosphate (AMP), inosine, uh, and hypoxanthine, and then termination of aerobic or termination of anaerobic glycolysis, and then additionally, where there's high lactate and and low glycogen, and mitochondrial, and where there's mitochondrial inflammation with amorphous matrix densities, and then disrupted sarcolemma, which seems to be a concluding, a sort of a concluding factor. A concluding factor. Reperfusion prevents sort of progression from reversible to irreversible injury by restoration of oxidative phosphorylation and washout of metabolites of glycolysis, such as lactate. And so now finally, looking at ischemic and reperfusion injury, as part of tissue injury. So ischemic reperfusion injury is a complex pathological process, and can be defined as damage to an organ or tissues caused during ischemia and reperfusion. IR injury, ischemic reperfusion injury, is encountered in a variety of medical and surgical interventions or procedures, including in around thrombolysis, coronary angioplasty, and through solid organ transplantation, and sort of in around cardiopulmonary conditions. At the same time, novel concepts have been developing to better understand the sort of science that surrounds ischemic reperfusion injury. In the next audio podcast, as part of this series, there'll be a look at a sort of overview of ischemic reperfusion injury by post conditioning, and looking at the concept of ischemic reperfusion injury by post conditioning through an iteration of a schematic a schematic as part of sort of published works from 2007 that had formed part of this works from 2008. So that draws this audio podcast to a close. This audio podcast is part of the Ghromulin series. This audio podcast as part of a Photon Saga, and this audio podcast as part of a Storm Robotics production.